Welcome back everyone. So for this special lecture which we are doing, I'll start with a new subtopic that is on binomial distribution. Okay, so binomial distribution is one particular kind of a discrete distribution. Okay, we had seen different kinds of distributions. One was continuous probability distribution and one was discrete probability distribution. So discrete probability distribution was the case when the random variable was a discrete random variable. So one particular case of such discrete random distributions is binomial distribution. Okay, this is one of the easiest and one of the most common distributions in case of the discrete random variable. Okay, so let us see something over here about this. So the binomial distribution is dependent on the Bernoulli process. Okay, so the Bernoulli process is a process which has the following properties. Okay, so what are the properties over there? Okay, so the experiment, it's an experiment in which you keep on repeating the same thing again and again. Okay, you are tossing a coin, you toss a coin again and again, and so on, right? Or you're playing some game or something like in case of cricket we are playing a try series or something like that. We play the same match, we play the same ODI between the same two teams for 3 times. In case of a 5-match series, we play that match 5 times. Okay, so the same experiment is repeated some number of times, and each trial results in an outcome that can be classified as a success or a failure. Okay, so in case of a cricket match, it can be classified as a victory or loss for the team. In case you're answering some exam, it can be considered as pass or fail or something like that. Okay, but there are only 2 possibilities of an outcome. Either you get success or failure, heads or tails, pass or fail or something like that. There are only 2 possible outcomes, and we'll call one outcome as success, second outcome as failure. Okay, we can decide what to call as success and what to call as failure. Okay, next, the probability of success is denoted by small p, remains constant from trial to trial. Okay, even though they are conducting the experiment again and again, the probability of success is a fixed quantity which will denote by p. Okay, now whenever, like for example, if you are answering the same exam again and again, if you fail in a paper, you get a repeat exam, right? So if you are answering the same exam again and again, your probability of passing actually changes. Why is that so? Because when you are under normal circumstances, when you are answering the same exam again, you will prepare more and go for the second attempt, right? Right now, you prepare more for the second attempt, plus you have some experience involved here, right? You have some experience involved that last time the paper was difficult, so I should study more this time, or last time the paper so and so questions had come, so I'll focus only on that question. So in such a situation, your probability to pass the exam changes from attempt to attempt. Okay, but this depends on factors. Some of people may not study anything for all their attempts, so for them it's the same thing, right? So in that case, it will not be a Bernoulli trial if your probability of passing changes. If it remains the same, then it is going to be a Bernoulli trial. Okay, like for example, you are tossing a coin, whether heads or tails comes, that will remain constant, whether you try 10 times or 100 times. Okay, the probability of getting a heads will remain the same. Okay, if the coin is same. Okay, even when a cricket match is being played, actually what happens is the players, they learn from their mistake and they can perform better in the next match. Okay, so that can happen, but otherwise if we ignore these assumptions, we can treat this exams or this cricket matches as a binomial process. Okay, if we ignore that the people are learning and they're becoming smarter, the players. Okay, next, the repeated trials are independent. So the outcome of one trial is not dependent on the previous trial. Just write this on the bracket over there. The outcome of one trial is not dependent on the previous trial or the next trial. Okay, so each trial is independent of the other. Okay, so however many times you perform the same experiment, it has no effect on what had happened in the past and no effect on what is going to happen in the future. That's the meaning of independent. Okay. Yeah, so what I was saying here is the right in bracket over there, the outcome an experiment is independent or is not dependent not experiment, you just say trial here, no? Trial will be a better word. Outcome of a trial is independent of the previous trial. So what happened in the previous exam or something, previous match, does not affect what is going to happen in this match. Okay. So next, now we'll define something called a binomial distribution. So we'll define a random variable for this distribution as follows. The number of successes in n Bernoulli trials is called as a binomial random variable. Okay. So we are performing a Bernoulli trials n number of times. The number of successes which you get, the number of times you pass the exam or number of matches you win, right, that will call as the value of x. Okay, and that's how we'll be working now. So the probability distribution of this discrete random variable is called as binomial distribution. Okay, and its values are denoted by small b. X is the value of the variable, n is the number of trials, and p is the probability of success. Okay, so for a given for a given experiment, keep in mind this n is the number of trials, this is the probability of success, and n and p are both constants. For an experiment, the only variable we have here is x. Okay, now the theorem over here which will help us in getting the value of the function, the distribution. So the theorem says that a Bernoulli trial can result in a success with probability p and a failure probability p and a failure with probability q 1, which is going to be 1 minus p. Okay, by the way, just to explain this, you can write this in the margin. There are only two possibilities for this experiment which we are trying. Okay, so what are this thing? One is success, okay, or failure, right? Then probability of success is this, and then the other possibility of the experiment is failure. So if this is the probability of success, what will be the probability of failure? We'll call it q. But what do we know? These are the only two possibilities of the experiment. So both the probabilities should add up and give you 1, right? But we know the value of p, so q can be easily found out as 1 minus p. Okay, so just write this in the margin and keep on. There are only two outcomes, each of them have this probability p and q, so their sum should be equal to 1. P plus q should be equal to 1 by the definition of probability, which we have studied earlier in the last chapter, right? So we can easily find out the value of q. Okay, so a Bernoulli trial can result in success with probability p and a failure with probability q, which is going to be 1 minus p. Then the probability distribution of this binomial random variable x, the number of successes, which is the number of successes in n independent trials, is going to be bx and p is going to be n choose x. Okay, n choose x, p raised to x, q raised to n minus x. Another way of writing this is this, n choose x. Some places they write it like this. Okay, I just followed the notation in the book. Okay, instead of writing ncx, they write n brackets like this. Okay, we'll just write it as this. e raised to x, q raised to n minus x. Okay. Yeah, so where x can take the values 0, 1, 2, 3 up till n. Okay, x is basically the number of successes. You can have at least 0 successes and at most n successes. You can't have more, can't have less. Okay. Yeah, so let us just derive this thing in 2 minutes. The proof of this theorem is very simple. So what you have to do is, the probability of success is p, okay, and probability of failure is q. Okay, success and failure. Okay, failure probability is this. So now you have n trials, right, in which n trials, you do n trials and get, oh wait on, this does not have that. Okay, and get k successes. I think so I made a spelling mistake, forget that. Okay, so and get k successes over here in n trials. So how can you get this k successes? You can have like for example, we are talking of winning and losing, right? So or success and failure will be better. Okay, let's do success failure only. So like, just take an example that we are doing this with 4 trials. V for W for success and L for failure. Okay, so now what is the probability of getting 3? We'll go for 2 successes. Okay, if you take x is equal to 2, that means 2 successes in 4 trials. Okay, so how can you do this? You can get it like W, you win 2 games and you lose the next 2, or you can win, lose, win, lose, alright, or win, lose, lose, win, lose, lose, win, win, right? And what else you can do? L, you can lose, win, win, lose, or you can lose, win, lose, win. Okay, there will be more possible. So how many such possibilities are there? I have not counted all of them. The total number of such possibilities will be 4, choose 2, right? Okay, from 4 of the possible options, you are choosing only 2 of them as W and rest you are putting as L. Okay, so it's going to be 4, choose 2. Next, what is going to be the probability of any of these things? Each of the trials are independent of each other, right? So what I can do is, there will be 4, choose 2 number of trials over here. And what is the probability of any one of them? If I take any one of them, what is going to be the probability? It's going to be probability of winning the first game multiplied by probability of winning the second game into probability of losing the third game and into probability of losing the third game, right? Or fourth game, sorry, right? Yeah, and this will become equal to p square q square. If you do this for the remaining people also, you get the same thing of p square q square only. You can easily verify, right? So what is going to be the probability or total probability of getting 2 successes in 4 trials? 2 successes in 4 trials will be p raised to 2, 2 times p will come, and q raised to 4 minus 2. So you win 2 games and the remaining games you lose. Okay, So out of the 4 games which are there, you win only 2 and the remaining you lose. So what is the remaining? 4 minus 2, right? Then how many ways can this be achieved? And how many ways can you win these games? There are going to be 4C2 number of ways of winning these games. Okay, I have shown some of them here. What is 4C2 by the way? Just 4 factorial upon 2 factorial upon 2 factorial. So this is going to become 4 into 3 upon 2, and this is 6. This is 6, right? How many I have written here? 1, 2, 3, 4, 5. Okay, so these are all the possibilities. So there are 6 ways in which you can win. You can win this. You can win 2 matches out of 4 trials. Okay. So now let us talk in general. General case where there are n trials. Okay, probability of k successes. What will this be? This will become, from n games you want to choose winning k of them, right? And the probability of winning each of the games is t. How many games you want to win? K, right? And the remaining you want to lose. So how many are the remaining games? N minus k. Clear? So this is how you get that formula over there. Okay, in the theorem, this is how this formula comes. Okay. So yeah, let's go on. So this is how this formula is derived. Clear? So let us see some exercises quickly. The probability that a patient recovers from a delicate heart operation is 0.9. What is the probability that exactly 5 of the next 7 patients having this operation survive? Okay, so let us solve this one. First example. We'll define something called success. Success, I think so I'm spelling the word success wrong here. It's SUCC. Wait, huh? Let SUCC ESS. Let success be defined as, okay, so let success be defined as surviving the delicate heart operation. Delicate heart operation. Okay, so this has to be defined. Then let X be the number of successes. Okay, double C. Successes. The number of success. Okay. So what is the probability of success? P is the probability of success. This is equal to 0.9. It's given over there. Okay. Then Q is going to be the probability of failure. And how much is that going to be? 1 minus P, that is going to become equal to 0.1. Okay. And they have already given you that N is equal to 7. Okay. What have they asked you in this question? They have asked you to find out B, 5, 7 0.9. Okay, this is BXNP. This is what we had seen, right? Okay, so what they have told us to find in the question is B57 0.9. So this is going to become, from 7 you want to choose 5 people to survive. Probability of surviving is 0.9, and that to the power 5, and then probability of death is going to be 0.1, which is going to be 7 minus 5. Okay, so this is going to be 7 choose 5, 0.9 to the power 5, 0.1 to the power 2. Okay, if I solve the problem up till here, I'll give you all marks on, because taking this pause is going to be very difficult without a calculator. You can't do them manually. Okay, so if you want, you can use a calculator and get the final answer to this question here, but that is not required. But what is important is writing all these things down. Let success be defined as, let x be the number of successes, probability of success, what is the probability of success, and what is the probability of failure. Okay, these 4 things should be written in the answer. If these things are not written, you all won't get marks. There's no, I'm not going to give marks for just writing this number down over there. Okay, this number has no meaning like that. Okay, so define everything properly and then calculate this quantity. Okay, so that's the first problem. Let's go to the next problem. A traffic control engineer reports that 75% of the vehicles passing through the checkpoint are from within the state. What is the probability then? Fewer than 4 of the next 9 vehicles that are from out of the state. Okay, be careful about what is being spoken here. I'll repeat the question. A traffic control engineer reports that 75% of the vehicles passing through a checkpoint are from within the state. So how many of them are from out of the state? 25%. Okay, so 25% of the vehicles are from out of the state. So what is the probability of fewer than 4 of the next 9 vehicles are from out of the state? Okay, so now realize that the probability of success which you want will be 25%, not 75% here, because the question is about how many of them are from out of the state. Okay, so let us solve this one. To let what was this? Yeah, let success be defined as spotting. What's the word spot used over there? We'll just say passing. Defined as an out of state means if within Goa there are some Karnataka vehicles moving by, there are some Maharashtra, Andhra, Telangana number plate vehicles moving by. Okay, so that's what I'm measuring. How many of them are not local number plates? So let success be defined as out of state vehicle passes through checkpoint. Let x be number of successes. Okay, let x be number of successes. It has to be written in plural. So es has to be coming here. Okay, let x be number of successes. Probability of success will be what? Probability of success will be 25%, that is 0.25. Okay, 25% is written as 25 by 100, that gives you this. So what will be the probability of failure? That will be 0.75. What is given as the number of trials they are going to do there? 9, I suppose, right? 9. 9. So they are asking more, what is the probability that success is less than or equal to, wait on. Okay, they said fewer than 4 vehicles are passing through, so it will be strictly less than. Okay, so probability of x less equal to strictly less than 4. Okay, for the previous problem we had not written this, it's not important, but we'll just write it. In this problem, our probability of x is equal to 5. This is what we were calculating here. Here we are calculating x less than 4. Okay, but what is going to be x less than 4? This is going to be probability of x is equal to 0, probability of x is equal to 1, probability of x is equal to 2, plus probability of x is equal to 3. Right? So, and what is each of this going to be? This is going to become 9 choose 0, 0.25 to the power 0 into 0.75 to the power 9 minus 0. Okay, next will be 9 choose 1, 0.25 to the power 1, and this will become 0.75 to the power 9 minus 1, that's 8. Okay, then next over here will be 9 choose 2, 0.25 the power 2, 0.75 to the power 9 minus 2, plus 9 choose 3, 0.25 to the power 3 into 0.75 to the power 9 minus 3. Okay, so we can write this in the form of summation also. X is equal to 0 up till 3, 9 choose x, 0.25 to the power x into 0.75 to the power n minus x. Oh sorry, there's 9 over here. Okay, okay, so if you want you can stop solving up till here, or if you want you can write it like this also in one step and finish the thing. Don't try to simplify this expression, it's going to be very lengthy to do manually. Okay, there are some shortcut tricks available in the book, but I don't want to teach all that right now because that's not going to help you. Anyways, there are softwares which calculate these numbers. That's how the book has done it. Okay, but I can't give all that software or that table for the exam. Okay, the book has one table also which was calculated using a software. I can't give all that table, so you'll just write up till here. That should be enough. Okay, so let's go to the next problem. A nationwide survey of 17,000 college students revealed that 70% of them disapprove of wait a minute, 70% of the students disapprove of daily pot smoking. Pot, I think so, is marijuana. Okay, I think so, that's the name for that. Okay, so okay, so anyways, this number 17,000 is not required, huh? Just strike it off. This is not relevant to this problem which we are solving it. This comes up later on for some other problem. So for the time being, you all don't distinguish. Okay, so a nationwide survey of college students, college seniors by the University of Michigan revealed that almost 70% of them disapprove of daily pot smoking. Okay, so if 18 of the seniors are selected at random and asked their opinion, what is the probability that the number of the students who disapprove of pot smoking daily are more than 9, students who disapprove of pot smoking are more than 9 but less than 14, anywhere between 7 to 9, at most 5, okay, and not less than 8. Okay, so let us solve this one. Okay, third question. Let success be defined as selecting a student who disapproves of daily pot smoking. Okay, so this is my success definition. Let X be number of successes. ES has to be added on because we are talking in plural. Okay, what is the probability of success? Probability of success, this is going to be equal to 0.70. Okay, it was given 70%, so 70 divided by 100 gives you 0.70. So Q is the probability of failure. Okay, failure. This is going to be 1 minus 0.7, this is going to be 0.3. Okay, N in this case is 18, I suppose. Okay, 18 is the number of trials. Done. What else we've done? Nothing else, right? So now let us this thing. So the first question is asking us so problem wants more than 9 but less than 14. So this is probability of X. They want X to be more than 9 and less than 14. Okay. See, they said strict. When they say more than 9, it means X is greater than 9. If they write more than or equal to 9, then you write less equal to sign over there or greater equal to sign. Okay. So more than 9 by default is supposed to be assumed as what do you call that, greater than 9. Okay, so this will be what? This will start from probability of X is equal to 10 plus probability of X is equal to 11. Okay, I'll write dot 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 probability of that was not required. There are only two cases here. Probability of X is equal to 12 plus probability of X is equal to 13. Just because of one person putting dot dot dots is not sensible. Okay, so this will write it as a summation. X is equal to 10 up till 13. So from 18 choose X. How many successes you want? 0.7 to the power x into 0.3 to the power 18 minus x. Okay, this is a very big calculation to be done now because there are 18 trials, so 18 choose x and all, that's going to be a very big number for you to sit and solve it. Okay, so just write it down like this only. Even if you try to do 18C10, 18C11, these are huge calculations. Okay, next, anywhere from 7 to 9. Okay, so now they have said anywhere from 7 to 9. So now from 7 to 9, so this actually includes 7. Okay, if they had said anywhere between 7 to 9, then it becomes strict. They have said anywhere from 7 to 9 means 7 and 9 are included. Okay, so this will become probability of x is equal to 7, probability of x is equal to 8, plus probability of x is equal to 9. So how will this be written in summation sign? This will be x is equal to 7 up till 9, 18c7, 18cx 0.7 to the power x into 0.3 to the power 18 minus x. Okay, done. Let's go to the next one. At most 5. So we have said at most 5. So at most 5 includes 5 in it. So at most means what? It can be 5 but not more than that. Okay, so that's the meaning of at most. At most 5 will mean what? It can be 5 but it cannot be greater than 5. But 5 is the largest number in that thing. Okay, so what should this be? X can take the value 0. It cannot take negative values, they cannot be negative successes. Okay, so this is x is equal to 1 dot 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 up till x is equal to 5. There are many, so I just put dot 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 this time. This write summation x is equal to 0 up till 5, 18 choose x, 0.7 to the power x into 0.3 to the power 18 minus x. Okay, what I'm changing in every problem only is the summation sign, if you notice it. Okay, so let's go to the next one. Not less than 8. So not less than 8 will mean what? Opposite of that. It should be greater than 8. It shall not, by the way, it should not be less than 8. So it can be equal to 8 over there. Okay, so it can be equal to 8, 9, 10 and so on. Okay, but it should not be less than 8. So 7 is not allowed, but 8 is allowed. Because 8 is equal to 8, it's not less than 8. Okay, so D is probability of x greater equal to 8. Okay, so this will become probability of x is equal to 8 dot 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 up till x is equal to, largest is going to be 18 here because there are 18 trials. Okay, so this will become summation x is equal to 8 up till 18. So from 18 I'm choosing x, and number of successes are x and number of failures are 18 minus x. Okay, so this was this example. I think so, yeah, we're done with this example. Let's go to the next one. In testing a certain kind of truck tire over a rugged terrain, it is found that 25% trucks fail to complete the test run without a blowout. Okay, the tires burst over it. That's what they're saying. So in 25% of the trucks, one of the tires gets punctured in simple language. Okay, they fail to complete means one of the tires is getting punctured. Okay, so out of the next 15 trucks tested, find the probability that 3 to 6 have blowouts or punctures, less than 4 have punctures, and more than 5 have punctures. Okay. Okay, let's do this one first. Actually, see, this problem kind of becomes inverted kind of now. See what I'm going to do here. So, this question. So, what am I doing? Let success be defined as the truck has a blowout. Okay, actually when you're performing this experiment, you want the trucks to complete the test without a blowout, without a puncture, right? But for this example, so success will actually should have meant that the truck passes the test without a, what do you call that, a puncture. But the way we have designed a problem, it is saying the negative over here. It is saying that the success is the truck has a puncture. Okay, so it's kind of a negative statement, but our information is given like that, and the question is asked like that: how many of them are having a blowout? They didn't ask you how many of the trucks are successfully completing the test. They are more interested in knowing whether the truck has a puncture or not. Okay, so that's why I'm defining my success like this. Okay, so let X be number of successes, P be equal to probability of P be the probability of successes, probability of success, single, not plural, success. This is going to be given as 0.25. Let me just check again what was said. Wait, 25% of the trucks fail to complete the test without a blowout. So the probability that the truck will have a blowout is 25%. Okay. By the way, they're testing all 6 tires of the truck. Even if one tire is punctured, the tire is rejected. The entire truck is described as a failure. Okay, but in our case, it's a success. Okay, we are not worried about what happens to all 6 tires. Even if one tire goes, we are going to count it over here. Okay. So probability of the truck having a blowout is 0.25. So Q, probability of failure is 0.75. By the way, the information given there is 25% of the trucks fail to complete the test without a blowout, right? So 25% of them are having a blowout. They fail to complete, that means they have a puncture over there. Okay, so that's what I've counted as 0.25 over here. Okay, probability of failure is this. N for this problem is given as 15. Okay, find probability of X from 3 to 6 have. Okay, so here they want this thing. From 3 onwards up till 6 they have puncture. So 3 to 6 of the trucks had this thing. So I assume all of you have learned the trick now. So let me write directly x is equal to 3 up till x is equal to 6. Number of trials is 15. Choose x. Probability of success is 0.25 to the power x and 0.75 to the power 15 minus x. Okay, so this is the answer for the A part. B part, let us see. Less than 4, fewer than 4 have a blowouts. So basically less than 4 have a blowout. So probability of x strictly less than 4. So this will become summation 15 choose x. This part I'll write first. 0.25 power x 0.75. Okay, less than 4, right? So maximum here will have to be 3. Start with x is equal to 0. So it can be that 0 trucks had a puncture, 1 truck had a puncture, 2 trucks had a puncture, or 3 trucks had a puncture. More than that is not allowed here. Okay, C, probability of what they want. More than 5 have a blowouts. So here we have basically the opposite of the previous one. So what should this be starting with? So starting with x is equal to 6 up till 15. 15 choose x 0.25. Okay, simple. Okay, so let's go to the next question. Okay, so in a certain city district, the need for money to buy drugs is stated as the reason for 75% of all the thefts. Okay, so because those drug addicts, they want money to buy more drugs, they are involved in robberies and other crimes. Okay, so find the probability that among the next 5 theft cases reported in this district, exactly 2 were resulted from the need to buy money for drugs. At most 3 of them resulted from the need to buy money for drugs. Okay, so the intention behind the crime is asked once they arrest the, what do you call that, they arrest the robber, they put him in jail and ask him why he committed the crime and all these things for legal processes. So that time they tell that they wanted to buy more drugs, so that's why they had to steal money, they had to perform some what do you call that, violent act or something like that. Okay, and get that money. So that's the thing. So let us define what is a success. Success is the theft was committed for money, for the need for money to buy drugs. Okay. Fifth question. Let success is the motive. That's right. That the motive behind behind committing the theft was money to buy drugs, was the need for money. the need for money to buy drugs. Okay, let X be a number of successes okay PB okay. How much was this given as? I forgot. Yes, I reported the question. 75%. Okay, so this is 0.75. Probability of failure will be 0.25. 1 minus 75, that will give you 0.25. And n for this experiment is 5. Okay, so probability of A part is probability of exactly 2. So x is equal to 2 exactly. This should become 5. Choose, there's only one thing, so no need for summation here. So from 5 choose 2, 0.75 into 2 power 2. This will become 5 minus 2, that will become 3. Okay, so this is the answer over here. This one you can, if you have calculators, you can sit and simplify. If the previous ones would have been too difficult to simplify, they would waste a lot of time. Okay, so this you can use a calculator, simplify and get the answer. But for exams, if you solve up till here, I'll give you all marks. Okay, at most 3 resulted from the need to buy money. So at most 3. So it can be at most 3, not more than 3. So 3 is included in this. Okay, so it can be at most 3, not more than 3. More than 3 is not allowed. Right, so this thing will be P probability of x less equal to 3, at most 3. So this will have to become summation I x values. X is equal to 0 up till 3, probability of x is equal to capital X is equal to small x. Okay, so this will become summation sign x is equal to 0. X cannot be less than 0. You cannot have negative number of successes. So successes can be at least a 0. Okay, not less than that. So 3. So this will become 5. Choose x 0.75. Okay, so this will be this. Okay, so this was this example. Let's go further. So now let's go to the next particular type of this thing. So we solved 5 examples here. Now let us go further to the next type of binomial distribution. So there's one special kind of binomial distribution that's called as a negative binomial distribution. Okay, so the number x trials required to produce k successes is in a negative binomial experiment is called negative binomial random variable. Right, so what do you mean by negative binomial experiment also over here? So in the previous one, what we were talking of is in the binomial distribution was we wanted k successes over there, or x successes, small x number of successes in n trials. Okay, But here what we are doing here is we are doing kind of the opposite. I'm saying that the kth success should come in the nth trial or something, or xth trial. Okay, so let me elaborate. So its probability distribution is called as the negative binomial distribution, okay, which you get from negative binomial random variable. So let me elaborate now on this. Beta, and the values instead of b, k, and p, they are given as b star, x, k. Okay, so basically you are getting x success in the k trial. Okay, so let me explain this now. If as a theorem, if the repeated independent trials can result in a success with probability p and a failure with probability q, that is 1 minus p, then the probability distribution of the random variable x, the number of trials on which the kth success occurs, is given by b star xp. Okay, this is x minus 1, choose k minus 1, and pk, q of x minus p. Okay, where k can be, x can be equal to, where x has to be some number greater than k. Okay, the meaning of this is x is greater or equal to k. Okay, so negative binomial distribution means what? You want x successes, right? Sorry, you want k successes, out of which the first k minus 1 successes, they can come in any way they want. I don't care in which trial we got success, which trial we got failure. I want k minus 1 successes in x minus 1 trials, and on the xth trial I want the success to come for sure. So what will happen? On the x trial I have exactly k successes. Okay, just giving all an example of this negative binomial distribution. Like for example, India Sri Lanka won 5 match ODI series is going on. Okay, 5 matches are being played. So now the question is, what is the probability that India can win the series in 3 matches? So for India to win the series in 3 matches, what should happen? They have to win all the 3 first matches. There is no choice over there, right? All the first 3 matches have to be won. But now, if I say I want India to win the series on the 4th match, so what I'm saying, that on the 4th match, India should win the 3rd game. On the previous 3 games, what happened? That I don't know. On the previous 3 games, I know that India has won only 2, and on the 3rd game, they won on the 4th ODI. Okay. Now, by the way, for those of you who don't watch cricket, if there's a 5 match series, for you to win that series, you require to win majority number of the games. Okay, so majority becomes 3. So if you win 3 out of 5, you get the series, you get the trophy for you. Okay, so if you want the team to win the series on the 4th match, it means that the 4th match has to be a success, and from the previous 3 matches you want only 2 successes, right, and 1 can be a failure. In which order, I don't know and I don't care, but what I want for sure is that the 4th match should be a success. Clear? Okay, so the proof of that is just wait off. Some problem occurred. The proof for this is very simple. We want kth success on xth trial. Okay, you want kth success on xth trial. So this means, thus in the previous x minus 1 trials, we want k minus 1 wait a minute, I'm a little dirty. We want k minus 1 successes. So what should happen? So thus, what is going to happen? What is going to be the probability here? So from x minus 1, you're choosing k minus 1 successes, right? In any order, let them happen, I don't worry. So I want here p to the power k minus 1, okay, and q to the power x minus 1 minus k minus 1. Okay, so this minus 1 and this minus 1 will become plus 1 and they'll cancel. Okay, so this is what should happen in x minus 1 this thing. And on the kth trial, just a moment, and on the kth trial I want a success, so that should be one single p alone here outside. So this is in k minus 1 trials and this is the kth trial. Okay, on the kth trial this happens, and k minus 1 trials this happens. In which order they are winning, that I don't know, but on the kth trial I want this. So if you simplify this now, this will become x minus 1, choose k minus 1, this is going to become p to the power k, right, and this will become q to the power x minus minus 1 is gone from here, minus 1 and plus 1 is gone, so this is going to become x minus k. Okay, the remaining terms cancelled each other. Sorry, this is p to the power k. Okay. Okay, so this is the formula. So simple derivation. So this will denote as b star. Oh sorry, the camera was on all this time. Okay. Extremely sorry. Okay, so this is what we had written. Yeah, so what I was writing here when you were looking at my face all this time was we want k successes on the x trial. We want a kth success on the x trial. So thus in the previous x minus 1 trials, we want k minus 1 successes. Okay, so what should be happening here is, in the first k minus 1 trials, I want this to happen. So in the first k minus 1 trials, I want k minus 1 successes, right? In the previous x minus 1 trials, I want k minus 1 successes. So that we have derived the formula already. So x minus 1, choose k minus 1, p to the power k minus 1, q to the power x minus 1 minus k minus 1. This is the formula which we have derived in the previous theorem, right? So in the k minus 1 trials, this is what happened. And then on the k trial, I want a success, right? So this is for k minus 1 trials gives you this, and this is the kth trial. Okay, so after simplifying, taking this, multiplying this inside, this will give you p to the power k. This minus 1 will cancel out with this minus 1, this becomes plus 1. Okay, and the remaining terms remain like this. Okay, so just pause the video and write this down. Sorry for the trouble. Okay. Okay, so if we have finished writing, let us go back to the yearly. Let's go further. Yeah, the next one is a geometric distribution. So geometric distribution basically is what we're doing is it's a specific case of the negative binomial distribution, okay, where we want the xth trial to be the first success. Okay, so we want the first success to come on the xth trial. Okay, so let me state the theorem. If repeated independent trials can be result in success with probability p and failure with probability q that's equal to 1 minus p, then the probability distribution of the random variable x, the number of trials, x is the number of the trial on which the first success occurs, is the given as gxp. P choose gxp gxp is p times q to the power x minus 1, where x is 1, 2, 3 and so on. Okay, so if this is a particular case of the last time with proof is very simple. I think so. Have I left place to prove here? No. Okay, proof is very simple. Last time we wanted the kth success on the x minus 2 on the xth trial. Now I want to, and yeah, the kind of the things are changed here. Wait. Proof is simple. So what we'll do is, you want the first success to come on the xth trial. Okay, so x is the number on which the first success occurs. So basically what happens is, you have failure on the first try, failure on the second try, failure on the third try, failure on the fourth try, and so on up till you reach x minus 1. Okay, up till you reach the x minus 1 trials, and on the xth trial you're going to get here is a success. So this is going to end up as p times q to the power x minus 1. So in the you perform the experiment x minus 1 times, you get all failures, and on the xth attempt you get your success. Okay, so what is the probability that you'll pass the exam on your 10th attempt? Okay, so passing means your first time you're clearing the paper. No, after passing you won't answer the exam again, right? So if you want to calculate what is the probability that you'll clear the exam on the first attempt, what is the probability you clear the exam on the third attempt, 10th attempt, 25th attempt, and so on, those kind of questions become geometric distribution. Okay, this is not so useful because this is kind of the particular case of the previous one only. Okay, so when you are solving problems you don't have to kind of remember too many things. And I have derived all the three formulas which I have used till now. I assume you'll have understood the derivation. So if you'll have understood the derivation of the formula, you don't have to by heart the formula. Okay, so it's very simple of how that formula was derived. So if you'll remember the derivation, there's no need to by heart this formula. If you'll have not understood, then you will have to by heart. If you'll by heart things, then your brains will become very heavy. Okay, and you will find the things difficult there. Okay, so let's move on. What happened here? I think so there's some problem now. Okay. So exercises. The probability that a person living in a certain city owns a dog is estimated to be 0.3. Find the probability that the 10th randomly interviewed person is the 5th one to own a dog. Okay, 10th person is the 5th one. Okay, so let us solve this one. Okay, so first question. Let success, here also we have to define success. Let success be defined as the randomly interviewed person owns a you don't have to write the word randomly over here. It is defined as the interviewed person owns a dog. Owns a dog. That is enough. Okay. Let success be defined as the interviewed person owns a dog. Let X be number of successes. Okay. Probability of success. This is going to be a 0.3. Right. Q is going to be probability of failure. It's going to be 0.7. Yeah. So owns a dog is 0.3. Yeah. So now probability they were asking for us this B star in this case. So B star 10th person is the wait a minute. What is the notation we were using? B star 10th person is the 5th person. Okay. B star 5. Okay. Probability of success is 3. So this will become, you want 9, 10 minus 1. So from 9, 4 people should be owning a dog, right? So success should be 0.3 to the power 4, right? And by the way, you should write this here. X is equal to 10 in this problem. K is equal to 5. Just write this out because I'm using those numbers here. Okay, so from the first 9 people, 4 of them should be owning a dog, and 5 of them should not own a dog, right? And then the 10th person who's interviewed should also have a dog. Okay, so this simplifies to 9C4, 0.3 to the power 5, 0.7 to the power 5. This is the formula which I have given you all. If you substitute, you will get this. But for understanding purposes, I prefer to write it like this. I write the extra one like this and then multiply it inside. Okay. So moving on. Yeah, next problem. Yeah, so next problem, find the probability that the flipping the coin or tossing a coin gets the third head on the 7th flip, first head on the 4th flip. Okay, third head on the 7th flip. Okay, second problem. Let X be not X, what is the success? Success be getting a head. Okay, the experiment just involves getting a head. Very simple question. Let X be number of successes. Okay, successes. Just a moment. Oh, in this problem, no, the thing changes, huh? Sorry. In this problem, no, this changes, and this is number of trials. And K is the number of successes. Okay. Just note this change, huh? Okay. Okay, number of trials. K, number of successes. Okay. P, probability of success. So this is going to be, what is P given for this problem? We know for a tossing a coin, probability of getting a head is half, or 0.5. It's not given in the question. We are supposed to know this information. Huh? This is an easy problem, no? Failure will be what? 1 minus this. That will be 0.5 again. 1 minus 0.5 is 0.5. Okay. So first thing what they're asking here is, they want on the 7th, forgot the question. What is the question? Third head on the 7th flip. They want K is equal to 3 on X is equal to 7. Okay, so this is B star 7, 3, 0.5. So this is going to be equal to, from 6 trials, you get 2 successes, right? 0.5 to the power 4, 0.5 to the power 2 and 4 failures. And then on the 7th trial, you get a success. Okay, so this gives you 6 choose 2, 0.5 to the power 3, 0.5 to the power 4. Okay. Next one is actually a geometric distribution question. Okay, but you can do it also straight away, but we are looking for G on the which trial? First hit on the 4th flip. So we are looking for is G4 0.5. So we are going to have 0.5. So the first 3 trials didn't result in success, 4 minus 1, and the 4th trial resulted in success. Okay. So this is what we call it as Q to the power of 4 minus 1 into P. I've written it like that. Okay, anyways, this is 0.5 to the power 3 into 0.5 to the power 1. You can easily multiply them. I'm just leaving them like that only. If you want to solve it using this formula, it can be done using that also. If you want to write this as B star, what will it be? B star on the 4th trial, I want the first success at 0.5. What should this be? So on the first 3 trials, there should be no success. So 3 choose 0, 0.5 to the power 0 into 0.5 to the power 3. So 0 successes, 3 failures in the first 3 attempts multiplied by a success on the 4th attempt. Okay, so 3 choose 0 is how much? There's only 1. Okay, from 3 you're choosing 0 things. There's only one way of doing it, that is doing nothing. Okay, so this becomes 1 into 0.5 to the power 0 is, anything to the power 0 is 1, by the way, into 1. This becomes 0.5 to the power 3 into 0.5. So exactly same thing what I've written above, right? So both the things give you the same thing, huh? Okay. So that's about this. Let's go further. Yeah. So the probability that a student pilot passes the written test for a private pilot's license is 0.7. Find the probability that the student will pass the test on the third try, or the second part is before the fourth try. Okay, so passing a test, if you pass a test, you don't have to answer the test again. So basically you are interested in knowing when is the first success. Okay. Okay, so let's do this one. Question number 3. Let success be defined as passing the test. Okay. Okay, let success be defined as passing the test. X be number of trials before or number of trials to get first success. Okay, passing an exam is kind of a geometric problem. Okay, so we are interested in the first success. Okay, so what is this? Yeah, P probability of success 0.7. Probability of failure will be 1 minus this, that is 0.3. Okay, 1 minus 3, that will be 0.3. Nothing else is required, right, for geometric problems. Yeah, so we'll pass the exam on the third try. So A part is x is equal to 3. So basically you're asking me g of x. On the third attempt you want to pass the exam with 0.7 probability. So basically what you're going to do, you're going to fail the first two exams. Okay, so fail the exam twice and on the third attempt you pass. Okay, so first time you failed 0.3, second time you failed 0.3, third time you passed 0.7. Okay, so this is the answer. Next question is before the fourth try. So before the fourth try means what? X is less than 4. So it has not reached 4, before 4 they said. But X is the number of trials, right? So can it be negative? No, right? So X has to be greater than or equal to 0. Now can it be equal to 0? No, right? Trials has to be a non-zero number. So it has to be strictly greater than 0. So X's starting number is 1. So basically this probability which we are looking for here is probability of X, this thing, this is equal to g of X, sorry, 1 comma 0.7. You pass in the first attempt, or you pass in the second attempt, or you pass in the third attempt. Okay, so this will become, passing in the first attempt will become 0.7 straight away and there is no failure. Passing in the second attempt means you failed once and then you passed. Passing on the third attempt means you failed twice and then you passed. Okay, so this is the answer. If I want, I can simplify this. I won't give extra marks for that. Okay, so this is the answer over here. Clear? So that's about this. Now the last thing is multinomial distributions for today. So multinomial, as the name suggests, binomial means what? Bi means 2, right? Bi means 2, tri means 3, and so on, right? Multi means basically more than 2. Okay, multi means more than 2. Okay, so multinomial distribution. If I press enter, it goes to the last slide. I don't know why. Okay, now it's good. So the binomial experiment becomes a multinomial experiment if each trial can have more than 2 possible outcomes. Okay, so binomial meant 2, more than 2 means multinomial. Okay, some examples where you can have more than 2 outcomes. If you are classifying a movie as good, average, or bad, or if you can give it a rating also, like 1 star, 2 star, 3 star, 4 star, 5 star, okay, that becomes a 5 thing. Okay, I have given only 3 things here: good, average, bad, but you can make it 1 star, 2 star, 3 star, up till 5 star. Okay, like that also you can do. Okay, so classifying children as underweight, fit, overweight. Okay, this can also be something. This is not a success failure problem. Success failure, there were only 2 options. Okay, so underweight, fit, overweight, you cannot classify it as success or failure. There are 3 options here. Okay, students according to classifying students according to their exam grades. So you have exam grades as O, A, B, C, D, up till E, I suppose, or F, I don't know. Okay, so that many categories you'll get, 4, 5, whatever number of grades you'll have. Okay, so let us see the result here. So in general, if a given trial can result in any one of the k possible outcomes, that is E1, E2, E3 up till Ek, with probabilities of P1, P2, P3 up till Pk, then multinomial distribution will give the probability that E1 occurs x1 times, E2 occurs x2 times, okay, and Ek occurs xk times. So in other words, like 5 students got O grade, 6 students got A grade, 3 students got B grade, 10 students got C grade, and so on. That's what I'm saying here. E1 O grade occurs 5 times, A grade occurs 3 times, B grade occurs 10 times, and so on. That's what is the meaning of this sentence here. Okay, in n independent trials, means in a class of 60 students, how many times did you get O grade, how many times did you get A grade, how many times did you get B grade? Notice that number of students getting each of the grades should be equal to n. Okay, we denote this joint probability distribution using the alphabet F, where x1, x2, x3 is the number of people who are getting E grade, O grade, and so on. P1, P2, P3 up till Pk is the probability of getting each of those grades, and n is the number of students in the class. Okay, just giving an example like that. Okay, clearly you can see that the sum of all the probabilities should be equal to 1. Okay, yeah. So now the formula over here: if a given trial can result in k outcomes, E1, E2, E3 up till Ek, with probabilities P1, P2, P3 up till Pk, then the probability distribution of random variables x1, x2, x3 up till xk, representing the number of occurrences. So we have more than one variable now. So previously we used to have only one variable, right? We used to have only one variable, that is x is the number of successes. But now we are not measuring that. What is x measuring? X measures the number of people who have got the outcome E1. X2 measures the number of people who have got outcome E2, and so on. Okay. So representing the number of occurrences of E1, E2, E3 up till Ek in n independent trials. So is given by f of this whole thing is equal to this bracket expression. So this bracket actually refers to permutation and combination thing. I'll explain what it means. Okay. So this bracket expression multiplied by P1, probability of getting E1 to the power x1, probability of getting E2 to the power x2, and so on up till probability of getting Ek to the power xk. Okay, with the sum of all xi should be equal to n and sum of all probabilities should be equal to 1. Yeah, what is the meaning of that notation? I'll just tell you here. Where that notation means this, okay. So basically this is an extension of this NCR notation. I had told you all this NCR is also written as NR over here, right, in one of the earlier slides. So this is basically N R factorial upon N minus R factorial. This is how we used to write, right? But in general, if you have x1, x2, x3 up till xk, it becomes like this: n factorial divided by x1 factorial, x2 factorial up till xk factorial. So basically this was R1 and this was R2. Okay, this is a special case, this is the general case. So you can just say that this is general form of NCR notation. Okay, this is the general form of NCR notation. Okay, finish writing. So in the original binomial problem we had NCR, but now we don't have we had NCX over there. Now we don't have NCX, we have NC x1, x2, x3 up to so on. Okay. So let's see one example. So the probabilities are 0.4, 0.2, 0.3, 0.1 that are respectively that a delegate will come for a certain meeting or a convention by air, bus, automobile or train. Okay, so the probability he'll come by air is 0.4, probability he'll come by bus is 0.2, probability he'll come by train, probability he'll come by his own car is 0.3, probability he'll come by train is 0.1. So what is the probability that among the 9 delegates randomly selected at this convention, 3 arrived by air, 3 arrived by bus and 1 arrived by automobile and 2 arrived by train? Okay, so let us solve this problem and then we are done. So let x1, oh wait, I have to define E1 first. E1 be the event when that delegate comes by bus, okay, the delegate comes by bus, first thing what? Air, sorry. Delegate comes by air. E2 be the event, delegate comes by bus. E3 be the event, delegate comes by automobile. E3 and E4 is the event, he comes by train. Okay, so what is probability now of E1? These numbers are given over there. Probability is E1 is 0.4. We'll call this as P1. Okay, P2 will call it as probability of E2, that is going to be 0.2. P3 will be probability of E3, that will be 0.3, and P4 will be the probability of this E4, so that we'll call it as 0.1. Observe that the sum of all these things P1, P2, P3 plus P4 is equal to 1. Okay. So how many people are coming in total for this convention? 9 people we are checking. Okay. 9 people are coming for the convention. So what are we looking for? We are looking for 9 Out of those 9 people, sorry, we are looking for f of for f of 3, 1, 2 given probabilities of 0.4, 0.2, 0.3, 0.1, comma 9. This is what we are looking for. And what is the answer to this? This is 9, 3, 3, 1, 2 and 0.4 to the power 3, 0.2 to the power 3, 0.3 to the power 1 and 0.1 to the power 2. Okay, so just simplify this expression. This is 9 factorial upon 3 factorial multiplied by 3 factorial multiplied by 1 factorial multiplied by 1 factorial multiplied by 2 factorial, okay, into 0.4 to the power 3, 0.2 to the power 3, 0.3 to the power 1, 0.2 to the power 0.1 to the power 2. Okay, so with that we are done with all the examples. So let me just recall, I have done 4 different things today. Let me just recall about what each one of them corresponds to. Okay, so let me just write over here. What are the 4 things I have done today? Binomial, negative binomial, okay, geometric, and this is multinomial. Okay, so what is the thing in binomial? Two outcomes, and we want k successes. Oh, sorry, we were using x successes. We want x successes in n trials. Okay, what is the probability of getting x successes in n trials? That was the question. Negative this thing, again 2 outcomes, but here what we are looking for is the x success. One second. How did I define it? So here we want the kth success on the xth trial. Okay, geometric, what we are doing, same thing, 2 outcomes are here, but here we want the first success on the xth trial. So it's a particular case of the previous one. Instead of k, I'm just writing k is equal to 1 over here. Multinomial is more than 2 outcomes. Okay, all the formulas look similar, but they have their own uses. Okay, so if the question is asking you to find probability of x successes in n trials, it's a binomial distribution. Okay, if the question is asking you to find k successes in, what is the probability of getting the kth, oh I should mention here specifically, the kth success on the xth trial. Okay, the kth success should come on the xth trial, and the geometric means the first success should come on the xth trial. The is very important here. Okay, and multinomial means more than 2 outcomes. Okay, so that's all for today's lecture. It became very long and lengthy, almost, I suppose, how long, 1 or 40 minutes, and it's 6 o'clock in the evening and I'm still recording this class here. So bad for me. I should feel bad for me, you know, I'm waiting until 6 o'clock to record this class for you. Okay, because I didn't come to class today. Okay, so that's all for today. Bye bye, tata, have a good holiday. Bye bye. Go, put off.